Hello there, and welcome to the Sleepy Science Channel. Tonight's journey takes us far beyond the edges of the universe we know. Past the galaxies, past the faint afterglow of the Big Bang, into the possibility that ours is not the only universe. Some scientists picture a vast ocean of bubbles, each its own cosmos, endlessly drifting. Others see an infinite space, full of countless versions of ourselves. There are theories where every quantum choice creates a new branch of reality, and others where black holes blossom into entirely fresh worlds on the other side. Some of what we'll explore may feel close, as if another version of you might be just out of reach. Some will feel impossibly strange, stretching imagination until it bends. All of it will invite wonder about how small and how vast our own universe may be. If you enjoy these gentle journeys, consider liking and subscribing. Or share your thoughts down in the comments. It helps others find their way here too, one sleepy soul at a time. But for now, you don't need to do anything at all. Just settle in, let your breathing slow, and allow your thoughts to drift a little lighter. Let the day fall quietly behind you, and let the vastness of the multiverse open like a calm horizon ahead. Now, if you're ready, let's begin. Some theories suggest black holes may be gateways to entire new universes. Black holes are often described as bottomless pits, places where matter and even light fall in, never to return. But some physicists have suggested that instead of being dead ends, they could be beginnings. Inside, where gravity grows unimaginably strong, the collapse might trigger a rebound, a kind of hidden Big Bang that creates a brand new universe sealed off from ours. From the outside, all we see is a dark horizon. But on the inside, space itself could be expanding, galaxies forming, stars igniting. Our own universe may even have started this way, as the interior of a black hole in some older cosmos. It's impossible to look past the horizon to know for sure, but the idea turned black holes from tombs into cradles, quiet gateways through which reality may endlessly renew itself. String theory predicts as many as 10 to the 500 possible universes. String theory was born as a way to unify all the forces of nature. Instead of point-like particles, it imagines tiny vibrating strings, their different modes of vibration giving rise to all the particles we know. But one consequence of the theory is a staggering landscape of possibilities. Depending on how extra dimensions fold, how energy settles, and how the laws take shape, the theory allows as many as 10 to the 500 different universes. That number is so vast it defies comprehension, far more than there are atoms in our universe. Each universe in this landscape could have different particles, different constants, even different numbers of dimensions. Most would never allow life, but some might. If string theory is correct, then our cosmos is just one point in an endless mathematical archipelago, and the multiverse is not strange at all, it's inevitable. In an infinite cosmos, there could be another you, living a nearly identical life. Infinity is a strange concept. If space truly stretches on without limit, then every possible arrangement of matter must eventually repeat. Somewhere, unimaginably far away, there could be a planet that looks exactly like Earth, circling a star, exactly like our sun. On that Earth, someone who looks like you may be sitting or lying down right now, thinking similar thoughts, maybe even listening to words like these. A little farther still, there might be a version almost like you, but whose life took one tiny different turn, a missed bus, a different friendship, a new path entirely. Given infinity, every variation must occur, over and over. It's a mind-bending idea that you are not unique in the vastest sense. And yet, here, In this universe, in this moment, you are. The paradox of infinity is both humbling and strangely comforting. The many worlds interpretation means every decision you've ever made still exists, somewhere. Quantum mechanics suggests that particles don't settle into one state until they're observed. In the 1950s, physicist Hugh Everett proposed that instead of choosing one outcome, the universe splits. Every possibility happens, but in separate, parallel worlds. In one universe, you turned left. In another, you turned right. In one, a coin landed heads. In another, tails. Every quantum event is a fork in the road, and the cosmos takes all paths. If this interpretation is correct, then every decision you've ever made, and every one you didn't, still exists, carried forward in another reality. You will never meet those other selves, and they will never meet you. But in the quiet fabric of the multiverse, they are as real as you are. Every possibility is written somewhere, and reality itself is the author. Bubble universes might collide, leaving scars across the cosmic microwave background. Our universe began in a hot burst of expansion, but some theories suggest it was just one bubble in a frothing multiverse. Imagine space as a vast field, with bubbles of inflating energy blossoming outward. Each bubble is a universe, expanding and cooling, making stars and galaxies. Sometimes, bubbles might collide. If they did, the collision could leave an imprint, a subtle ring or bruise, on the faint afterglow of the Big Bang, known as the cosmic microwave background. Scientists have searched for such scars, looking for patterns in that ancient radiation. So far, the evidence is uncertain, but the possibility is haunting. Our universe may have brushed against another long ago, leaving only a quiet echo in the sky. The background hum of the cosmos might not just tell us of our beginning, but of neighbors we can never reach. Our universe may have been born inside a black hole in another universe. One of the strangest possibilities in cosmology is that universes give birth to universes. In this picture, every black hole in one cosmos becomes the seed of another. At the core of a collapsing star, where gravity crushes everything past imagination, the equations hint at a rebound. On the other side could be an expansion, not in our space, but in a new one. If so, our own Big Bang may have been the bounce from a black hole in a larger parent universe. In turn, every black hole in our skies could be a nursery for worlds we'll never see. The multiverse, then, would not just be vast, but endlessly generative, each cosmos sprouting others like branches of an eternal tree. We cannot know for sure, but the thought turns every black hole into a hidden beginning. The laws of physics themselves may change from universe to universe. We take the laws of nature as fixed. Gravity pulls. Light travels at a constant speed. Atoms bind in predictable ways. But some multiverse theories suggest these laws are not universal at all. Each universe might have its own settings, different strengths for forces, different masses for particles, even entirely different rules. In some, stars might never form. In others, chemistry might not exist. A slight change in the charge of the electron, for instance, would unravel atoms as we know them. And yet, here in our universe, the settings seem tuned in a way that allows complexity and life. Some see this as luck. Others argue that if enough universes exist, it is simply inevitable that one will have the right recipe, and we find ourselves in it. To live here is to dwell in the outcome of cosmic possibility. Some universes might exist with more than 3 dimensions of space. We move through length, width, and height, 3 dimensions that feel complete. But mathematically, there is nothing preventing more. String theory, for instance, works best with 10 or 11 dimensions. In those scenarios, our familiar 3 may be only part of the picture. The extra ones might be curled up so tightly that we never notice them, folded smaller than atoms, hidden in the fabric of reality. In other universes, those dimensions might not be hidden at all. Imagine a cosmos where beings move not just left and right, up and down, forward and back, but along directions we cannot even picture. To them, our space would seem strangely flat. To us, theirs would be beyond imagining. The multiverse may not only be vast, but layered in ways our minds can barely approach. Others might have no stars at all, only endless darkness. Stars define our universe. They forge the elements, like the night, and hold planets in their embrace. But not every universe need have them. If the forces of nature were slightly different, if gravity were weaker, or nuclear fusion impossible, then clouds of gas would never ignite. The result would be a cosmos without suns, without galaxies, without the familiar scaffolding of light. In such a place, matter might drift forever in cold silence. There would be no warmth, no planets, no sky. To us, it feels desolate. Yet it would still be a universe, unfolding according to its own rules. The multiverse reminds us that what we call normal is fragile. A little change, and the cosmos itself becomes a different story, one written entirely in darkness. Quantum fluctuations could be spawning whole new universes right now. At the tiniest scales, space is never truly empty. It seethes with quantum fluctuations, brief surges of energy that appear and vanish in an instant. Some theories suggest that, under the right conditions, such a fluctuation could balloon outward, igniting inflation and becoming an entire universe. If this is true, then the multiverse is not just a collection of past events, but an ongoing process. Even as you breathe, new universes may be budding somewhere in the deep fabric of reality, expanding into realms we will never touch. Each would begin with its own Big Bang, its own laws, its own history. To us, they are beyond reach. But to the multiverse, they are as natural as waves on an endless sea. Creation may never stop, it only shifts location, bubbling into being wherever possibility allows. 21. Some universes could have stars that burn cold and dark. In our universe, stars are dazzling furnaces. They shine because nuclear fusion at their cores releases tremendous energy as light and heat. But the rules of physics are not universal across the multiverse. In another cosmos, fusion might operate differently, producing stars that smolder instead of blaze. They could release their energy in wavelengths invisible to human eyes, faint glows in the infrared, or perhaps radiations we don't even have names for. To us, such a universe would look dark and lifeless, an empty expanse with no visible suns. But within it, cold stars could still be holding planets, binding systems together, and shaping the rhythm of that universe's story. For life that evolved there, if it were possible, a dark sky filled with invisible stars would feel perfectly normal. To them, our blazing yellow sun might seem impossibly bright and alien. 22. There may be universes where gravity is repulsive instead of attractive. Gravity is the architect of our cosmos. It draws particles together, builds stars, sculpts galaxies, and binds planets into orbits. But imagine a universe where gravity pushes instead of pulls. Instead of clumping, matter would scatter. Stars would never ignite, planets could never gather, and galaxies would never form. The universe would be a diffuse haze of particles, always flying apart faster and faster, an eternal expansion without structure. To us, it would seem utterly empty and hostile, a universe without any of the anchors that make ours familiar. And yet, such a universe would still be real, obeying its own rules with perfect consistency. If consciousness was somehow possible in such a place, it would know no other way. What feels strange to us would feel inevitable to them. In the multiverse, even something as fundamental as down might not mean the same thing everywhere. 23-point time itself might not exist in certain universes. We live within time so completely that it feels impossible to imagine its absence. Every moment has a past, a present, and a future. But in some theoretical universes, time may not exist at all. Instead of events unfolding, everything would simply be, a frozen block of existence with no before and no after. To us, such a cosmos feels lifeless, because motion, change, and history all depend on time's flow. But to the beings of such a universe, if any could exist, the absence of time might feel natural. Consciousness itself might not take the form of a sequence of thoughts, but instead exist as a timeless state of awareness. For us, it's unimaginable, because even our imagination depends on time. But the multiverse may include realms where the most basic assumption, that time must tick forward, simply does not apply. 24-point some versions of the cosmos may contain no matter at all. Matter is the foundation of everything we see: galaxies, stars, planets, even ourselves. Yet matter is not inevitable. In some possible universes, conditions at the beginning may have prevented particles from forming. Instead of atoms, protons, and electrons, there would only be energy, endless radiation streaming through space. Such a universe might glow with light, but it would never condense into stars or worlds. It would be a cosmos without solidity, a stage without actors. To us, it feels barren, even meaningless. But in the framework of the multiverse, it is simply one more variation, no less real than our own. The fact that our universe produced matter at all, let alone matter that could build galaxies and living beings, is remarkable. It makes our existence feel like the rarest outcome, a delicate balance in a sea of other possibilities. 25-point in an infinite multiverse. Every possible history must eventually occur. Infinity changes everything. If the multiverse truly stretches without end, then every possible arrangement of matter, every possible sequence of events, must eventually play out. Somewhere, there is a universe where Rome never fell. Somewhere else, one where the asteroid missed Earth and the dinosaurs still rule. Every great turning point in history, every small personal decision, would be written in infinite variations. The sheer scale of it is overwhelming. No single story is unique, because infinity ensures that all stories exist. Yet there is comfort in that, too. In this universe, this particular history is ours alone. We may not be unique in the grandest sense, but the version we are living, this exact moment, this path, is something we experience only once. The multiverse makes history endless, but it also makes our own thread precious. 26-point. There could be a universe where dinosaurs never went extinct. 65 million years ago, a vast asteroid struck Earth, ending the age of the dinosaurs. But in another universe, perhaps the asteroid missed. Dinosaurs would have continued to evolve and dominate the planet, adapting to climates and landscapes that changed over millions of years. Mammals may have stayed small and hidden, never taking over the world. In such a universe, intelligent life might not look human at all. It might be reptilian, descended from raptors or other agile predators, shaping tools with claws instead of hands. The Earth would look familiar in its mountains and seas, but utterly alien in its inhabitants. It's a striking reminder of how fragile our history is. One rock from space made the difference between our existence and a planet that would still belong to the dinosaurs. In the multiverse, both versions may be equally real. 27 point in another, humanity may have never evolved at all. Our species' story is built on chance. Tiny evolutionary shifts, climate changes, migrations, and extinctions all paved the way for humans to appear. In another universe, that chain might have broken. The Earth there could be filled with forests and oceans, alive with animals, but no humans to look at the stars. Intelligence might have taken another form, dolphins developing language, birds growing larger brains, or it may never have arisen at all. That Earth would be vibrant, but silent of human voices. It is a humbling thought that our existence depends on so many fragile accidents. In the multiverse, there may be countless worlds where humanity never happened. And yet, here we are, on this Earth, in this universe, witnesses to the cosmos. That rarity makes our presence feel not just accidental, but miraculous. 28 point some universes could be filled entirely with black holes. In our universe, black holes form from the collapse of massive stars. They are scattered across galaxies, rare compared to stars. But if the balance of forces were different, black holes could dominate. Imagine a universe where stars collapsed almost instantly after forming, merging into larger and larger black holes. Eventually, the whole cosmos could become nothing but a sea of horizons, each one hiding an unknowable interior. To us, such a place would feel hostile. No starlight, no galaxies, no familiar structures. But it would still be a functioning universe, ruled by gravity alone. And, within it, who knows what possibilities might unfold. Perhaps even those black holes, in turn, could be birthing new universes of their own, each hidden beyond its event horizon. What looks like an end from here may be a beginning elsewhere. 29 point others may be so diffuse that galaxies never form. The galaxies we see are the result of matter clumping under gravity. But if the density of matter were just a little lower, clumps would never take shape. In that universe, matter would remain evenly spread, a thin mist stretched across space. No galaxies, no stars, no planets, just particles drifting forever, never close enough to ignite into light. To us, such a cosmos would feel empty. Yet it would still exist, expanding quietly, a universe without landmarks or constellations. It shows how finely balanced our own cosmos is. Increase the density a little, and the universe collapses. Lower it, and nothing ever forms. In the multiverse, every balance may play out somewhere, including those where nothing more complex than a drifting atom ever appears. 30 point some universes may only last a fraction of a second. Our universe has lasted nearly 14 billion years, with galaxies still forming. But not every universe is so durable. In some versions, the laws may be unstable. As soon as they begin, they unravel. These universes may exist for less than a heartbeat, collapsing before stars or matter can organize. They flare into existence, then vanish as though they never were. To us, they are unimaginable, but in the framework of the multiverse, they count just as much as ours. Creation does not promise permanence, it only promises possibility. Even a universe that lasts an instant is still part of the great expanse. Somewhere, right now, new universes may be flickering into being, and disappearing just as fast, sparks in the endless night of reality. There might be universes that recycle themselves endlessly in cosmic cycles. In our universe, time seems to move forward in a long, open stretch. But what if some universes don't simply expand and fade away? What if they breathe? Imagine a cosmos that grows vast, collapses back in on itself, and then begins again. An endless rhythm of birth, death, and renewal. Each cycle might erase what came before, or perhaps leave faint echoes, whispers of old worlds folded into new beginnings. Civilizations could rise and fall an infinite number of times, never knowing they are part of a pattern. For us, time feels like an arrow. But in such a universe, it would be more like a circle, without beginning or end. Existence itself would be a heartbeat that never stops. Some universes may be governed entirely by quantum randomness. Our reality balances chance with law. Particles jitter unpredictably, but the larger world follows rules we can measure and trust. Yet, in another universe, rules might vanish, leaving only randomness. Every event, every atom, every breath of energy would be unpredictable. Stars might flicker into being and collapse at once. Planets could form, dissolve, or never exist at all. Even time might jump forward and backward, refusing to flow smoothly. To us, this sounds like chaos. But for any beings that arose in such a world, it might feel natural, the same way we take our laws of physics for granted. A universe of pure chance would be alien beyond imagining, a place where nothing could ever be repeated, not even for a moment. Others might follow strict deterministic laws with no chance at all. Now imagine the opposite. A universe where chance does not exist, where everything unfolds with mechanical precision. Every particle moves exactly as it must. Every star ignites at a destined moment. Every thought, every action, every future is written from the start. In such a place, free will would be an illusion, because every possibility was already decided long ago. The universe would be like a vast clock, ticking in perfect order, never deviating, never surprising itself. To us, that sounds stifling, but for inhabitants of such a cosmos, it might feel like comfort, a reality where nothing is uncertain and nothing is ever out of place. In this version of existence, destiny is not a story we tell, but the only possible truth. Some physicists believe the multiverse could be infinite in every direction. When we look into the night sky, we see billions of galaxies. But some scientists suspect this is only a tiny patch of reality, and that beyond it lies more, not just more galaxies, but more universes. And not just many, but infinite. If true, then every direction is endless. There is no boundary, no edge, no final horizon where it all stops. Infinity is difficult for the mind to hold. It means that somewhere, in that boundless sprawl, every possibility must eventually happen. Not once, but endlessly. There would be no limits, no ceiling on imagination. If reality is infinite, then every dream, every story, every version of you is already written in the stars, waiting in another world. In that case, there would be endless copies of this very moment. If the multiverse is truly infinite, then this very instant, you listening, your surroundings, every detail, may exist elsewhere. Not once, but again and again, repeated without end. Some of those moments would be identical. Others would be nearly the same but slightly altered. Maybe your shirt is a different color. Maybe a bird flew past your window instead of sitting still. Or maybe the differences grow larger, a different city, a different Earth, a different history altogether. The thought is dizzying. This very breath may be taken an infinite number of times, by infinite versions of you, across infinite universes. Infinity does not just stretch outward in space, it stretches into identity itself. A universe with slightly different physical constants might collapse instantly. Our universe exists only because its numbers are balanced with astonishing precision. If gravity were just a fraction stronger, or if the charge of the electron shifted slightly, the cosmos could not hold itself together. Some universes, with constants only a little different, might collapse in less than a heartbeat. Matter would never settle. Energy would never stabilize. They would wink out as quickly as they began, disappearing into silence. It reminds us how fragile our own reality is, resting on the knife's edge of possibility. A few changed numbers, and everything we know would never have had the chance to exist at all. Another with different constants might never stop expanding. The other extreme is just as strange. Imagine a universe where the push of expansion is too strong. Galaxies would race apart faster than gravity could pull them together. Stars might never form. Planets would never gather. Life would never have a place to take hold. Instead, everything would remain scattered, thin and cold, rushing apart into an eternal emptiness. To us, such a universe sounds desolate, but in its endless expansion, it might still be beautiful, a storm of energy stretching forever outward, never pausing, never slowing, a creation without pause. Some universes could allow elements beyond our periodic table. The elements we know, hydrogen, carbon, oxygen, iron, build everything from stars to skin. But those elements depend on the delicate balance of forces in our universe. Change those forces, and entirely new elements might exist. Imagine atoms with structures our chemistry cannot describe. Crystals that glow in colors no human eye could see. Materials harder, stranger, or more luminous than anything in our world. Entire planets might form from substances we could not even name. Life, if it emerged, would be made of unfamiliar matter, unrecognizable to us. In such a universe, even the simplest rock could be a wonder beyond imagination. Others may not allow chemistry to exist at all. On the other hand, some universes may never know elements at all. If the forces of nature were slightly altered, atoms could never bind together. There would be no molecules, no water, no air. Matter would remain as a featureless soup of particles drifting endlessly without form. A cosmos without chemistry would be empty of complexity. Stars and planets might never arise. Life, at least as we understand it, would be impossible. It is humbling to realize that everything we know, every flower, every ocean, every living being, depends entirely on the fragile dance of chemistry. Remove that, and the universe is silent. Somewhere, stars might shine with colors our eyes cannot imagine. Light in our universe stretches across a spectrum: red, orange, yellow, green, blue, violet. But that's only what our eyes can see. Other universes with different physical laws might produce starlight in entirely new ranges. Imagine skies glowing with hues beyond human comprehension, colors that no word could describe. Perhaps stars would shimmer in shifting tones, or burn in shades our minds cannot even picture. To creatures evolved in such a place, those colors would feel ordinary, the way blue and green feel to us. But if we were ever to glimpse them, they would appear as living wonders, lights of an alien rainbow spread across the heavens. Some universes could be only two-dimensional. Imagine a cosmos where everything is flat, no depth, only length and width. In such a universe, creatures would live like shadows on a sheet of paper, unable to conceive of up or down. Physics itself would change, because gravity as we know it depends on 3 dimensions of space. Stars, planets, even atoms might not form the same way, if at all. Yet, mathematicians can describe such worlds with precision, and they offer insights into how the laws of nature scale with dimension. A 2-dimensional universe might seem limited, but it could hold patterns and geometries forever inaccessible to us. The idea reminds us that our 3-dimensional space, so natural to us, may not be the only way reality can be arranged. Somewhere, perhaps, an entire cosmos exists as a living, endless page. Others might unfold across 10 or 11 dimensions. String theory suggests that our universe might not stop at the 3 spatial dimensions we know. Instead, reality could unfold into 10 or even 11 dimensions, most of them curled up so tightly we cannot perceive them. These hidden dimensions might explain why particles behave the way they do, or why gravity seems weaker than the other forces. If true, the cosmos is far richer than our senses allow, a multi-layered expanse where unseen directions quietly shape everything around us. In such a universe, moving sideways into a hidden axis could lead to spaces completely detached from our world. Entire realities might lie only a fraction of a millimeter away, yet remain invisible and unreachable. The possibility of 10 or 11 dimensions stretches the imagination, suggesting that what we call space may be just a sliver of a much larger whole. Our universe may be just one brane, floating in higher dimensional space. According to brane cosmology, our universe could be a 3-dimensional brane, short for membrane, floating in a higher dimensional sea. Other branes might drift nearby, each carrying its own universe with its own laws of physics. Sometimes, 2 branes could collide, releasing unimaginable energy and creating something like a Big Bang. To us, it would seem like a universe born from nothing, but in reality, it might just be the echo of higher dimensional movements. This idea transforms the cosmos from a self-contained bubble into part of a vast, multi-layered reality. If brane theory is right, our universe is not alone. It is one sheet in an infinite stack of cosmic membranes, endlessly drifting, occasionally colliding, and forever shaping realities we may never see. Parallel branes could collide, creating new Big Bangs. In brane theory, the clash of parallel universes is not just a possibility, but perhaps the very origin of our own cosmos. When 2 higher-dimensional branes collide, the impact could release colossal energy, igniting a new universe in a fiery Big Bang. This cycle might happen endlessly: collisions, explosions, expansion, and then silence, until the next impact sets creation alight once more. If true, our universe is just one child among countless siblings, each sparked by the crash of cosmic sheets drifting through higher dimensions. This perspective suggests that Big Bangs are not rare, miraculous events, but part of a larger rhythm. Somewhere beyond our perception, branes may still be drifting, waiting for the moment when their silent motion brings forth yet another universe. Our own Big Bang might have been the result of such a collision. The singularity we call the Big Bang may not have been the beginning of everything, only the beginning of our visible universe. In brane cosmology, our universe was born when a neighboring brane collided with ours, unleashing an eruption of matter, energy, and space-time itself. This view means that before the Big Bang, there may have been other universes, other cycles of creation, hidden in higher dimensions. The fireball that gave rise to galaxies, stars, and us may have been nothing more than a ripple in a much larger cosmic ocean. If true, the Big Bang was not the first spark, but just one flicker in an endless chain of collisions and rebirths. Our universe, vast as it seems, might be only one story in a book that never ends. In some universes, dark matter might not exist. Dark matter makes up most of the mass in our cosmos, silently shaping galaxies with its invisible pull. But imagine a universe where dark matter never formed. Galaxies like ours might never come together, their stars drifting apart without the glue of unseen mass. The night sky in such a universe might be sparse and scattered, with few structures larger than lone stars. Without galaxies, planets, and life as we know them might never appear. And yet, such a cosmos could still exist, governed by physics just slightly different from our own. The absence of dark matter would change everything, not just the shape of space, but the destiny of worlds. It is a reminder that the familiar patterns of our sky are not inevitable, but the result of invisible ingredients that might not exist everywhere. In others, it could dominate everything. Now imagine the opposite, a universe where dark matter is not a hidden background, but the overwhelming majority of existence. In such a cosmos, galaxies might form rapidly and collapse into dense, invisible structures. Ordinary matter, the kind that makes up stars and planets, could be drowned out by the sheer mass of dark matter. Perhaps stars would form differently, glowing faintly within vast halos of unseen material. Civilizations, if they arose, would gaze into a night sky filled with shapes and shadows we cannot imagine, sculpted by a substance that bends light and gravity with ease. In our universe, dark matter is silent and hidden, but in another, it could be the main character, the defining force shaping every corner of the cosmos. Some universes may have far more powerful black holes than ours. Black holes are already among the most extreme objects we know, but in another universe, they might be even more powerful. If the laws of physics were slightly altered, black holes could form more easily, grow faster, or collapse into deeper singularities. Entire galaxies might vanish into their pull, their stars consumed within a cosmic blink. Some universes might be littered with supermassive black holes, so vast that light itself could never find a way out. To us, these worlds would seem like realms of eternal darkness, ruled not by stars but by invisible engines devouring everything. And yet, even in such universes, black holes might not only destroy, they could also give birth, spawning new realms beyond their event horizons. In others, stars might never ignite at all. Our universe owes its beauty to stars, furnaces of light and life. But what if the delicate balance of physics shifted so that stars could never ignite? In such a universe, clouds of gas might drift forever in darkness, too cold or unstable to spark nuclear fusion. There would be no suns, no galaxies, and no warmth to nurture life. Planets might still form, frozen and lonely, orbiting in endless night. To observers within such a cosmos, the idea of light itself might be mythical, a force they could never witness. This kind of universe highlights just how precarious our own is. The stars above us, so constant and eternal in appearance, are actually the result of an exquisite balance. Change it even slightly, and the night sky could vanish forever. Somewhere, life may flourish in unimaginable forms. Finally, picture a universe not just with different stars or laws of physics, but with entirely new possibilities for life. Creatures might emerge in oceans of liquid helium or within vast clouds of plasma where energy flows like rivers. Intelligence could take shape in ways we would not recognize, beings of magnetism, networks of quantum entanglement, or structures spanning light years across interstellar webs. What seems impossible here might be natural elsewhere. These universes remind us that life is a word we barely understand, tied only to our narrow corner of reality. Out there, beyond our universe, life may exist not as flesh and bone, but as something stranger, more resilient, and more beautiful than we can imagine. Other universes might be eternally sterile and lifeless. In our cosmos, life emerged from a delicate balance of conditions: stable stars, rich chemistry, and billions of years for evolution to unfold. But in other universes, even if matter clumped into galaxies and stars, the chemistry needed for life might never arise. There may be no carbon, no water, no stable molecules, only sterile matter drifting endlessly. Entire universes could bloom with light, yet remain utterly lifeless, with no creatures to look up at the stars or wonder at their existence. These barren worlds remind us how precarious our own story is. Life is not guaranteed, even in universes filled with suns and planets. And yet, the very possibility of lifeless universes makes our own even more remarkable. A rare pocket of reality where the cosmos awakened and began to wonder about itself. A universe could exist where light travels at a different speed. Light is the fastest thing we know, racing at nearly 300,000 kilometers per second. But what if, in another universe, that number were different? If light traveled faster, space might stretch more quickly, galaxies growing larger and thinner. If it were slower, stars might burn differently. Their balance of energy shifted. Communication across space would change too. Entire civilizations might live with horizons far closer or farther than ours. Even the ticking of time depends on the speed of light, meaning such a universe might unfold at a pace unrecognizable to us. Our speed of light feels universal, but it may be just one possibility among countless others, a cosmic dial set to one value in a multiverse where every setting exists somewhere, or where nothing travels faster than walking pace. Now imagine an even stranger possibility, a universe where the ultimate speed limit is not light, but something as slow as walking. In such a reality, no particle could ever rush, no energy could spread quickly, no star could flare across space. Everything would unfold in agonizing slowness. Civilizations, if they arose, living in worlds where distances are forever unreachable. Even a message to a nearby neighbor might take centuries to arrive, not because of vast space, but because nothing can move fast. To us, it sounds uninhabitable. Yet such a universe could still exist within the multiverse. Time itself would feel different there, every action stretched into eternity. What we take for granted, the speed of light as a cosmic constant, may simply be one of many settings written into the fabric of reality. There may be universes where entropy runs in reverse. Entropy, the tendency of disorder to increase, is one of the guiding arrows of time in our universe. But what if another cosmos ran backwards? Instead of chaos spreading, order might build naturally. Broken cups might reassemble, stars might burn hotter as time moves forward, and life might emerge at the beginning only to dissolve into simplicity later. In such a world, the flow of time itself would feel alien, everything trending toward perfection instead of decay. To us, it would look like a film played in reverse. Yet for beings within such a universe, it would feel natural. Entropy is not a universal law across all realities. It is simply the way our own unfolds. Somewhere else, the arrow of time might point the other way entirely. Some universes might not have space as we understand it. What is space? To us, it is the three-dimensional stage on which matter and energy move. But in another universe, there may be no space in the familiar sense. Reality might be a network of nodes, or a fractal lattice where positions are discrete rather than continuous. Movement might occur in jumps, like stepping from pixel to pixel on a cosmic grid. To us, Such a universe would feel suffocatingly strange. No smooth distance, no flowing motion, only leaps between fixed points. Stars, planets, and galaxies might never form, because the very concept of location would be alien. Yet such a world might still exist, showing us that space itself is not a given, but a condition of our universe alone. Others may not have time. Equally astonishing is the possibility of a universe with no time at all. In such a cosmos, nothing changes, because change requires time. There would be no before or after, no past or future, only an eternal, frozen state. From our perspective, this sounds impossible, but mathematically, timeless universes can exist. They may be static solutions to the equations of physics, structures that simply are without ever becoming. To any observer, if one could exist in such a place, life and thought would be meaningless, since both rely on time to progress. And yet, the possibility of a timeless universe forces us to reflect on our own. The flow of seconds, so constant and invisible, is not guaranteed everywhere. Perhaps time is as much a local phenomenon as stars or galaxies. Some universes may allow instant communication across any distance. Imagine a cosmos where distance is no barrier, where a message sent from one galaxy to another arrives immediately. In our universe, relativity forbids this, ensuring nothing travels faster than light. But with different physical laws, the speed of information might be infinite. Civilizations in such a universe could be truly connected, their voices reaching across billions of light years instantly. The vast loneliness we associate with space might not exist there at all. Stars, planets, and living beings could form webs of communication stretching across the cosmos, a living network of thought and energy. To us, it sounds like fantasy, but to them, it would be natural law. In a multiverse of endless variations, there may be places where silence never reigns, where the universe itself is alive with voices across infinite distance. Others may be locked in total isolation forever. The opposite is equally possible, a universe where nothing can ever be shared. Imagine a cosmos sealed in silence, where particles cannot interact, where no forces connect distant regions of space. Each part of reality would exist in isolation, never touching, never influencing anything else. Stars might form, but they would never share light. Planets might exist, but they would never orbit suns. In such a universe, even if life appeared, it would be utterly alone, unable to perceive or affect anything beyond its tiny corner of existence. To us, such a place would feel tragic, but to the laws of physics, it would simply be another possibility. The multiverse may hold not just worlds of connection, but also worlds of eternal solitude. In certain universes, stars may form from exotic particles. Our stars are made of hydrogen and helium, simple elements fused together under crushing heat. But in another universe, stars might burn with different fuels entirely. Exotic particles unknown to us, heavier cousins of quarks, or stable forms of matter that decay instantly here, might form the cores of suns. These stars could glow in colors unseen in our spectrum, or pulse with rhythms unlike anything we know. Entire galaxies might shine with alien light, built on chemistry beyond our reach. Such a cosmos would be unrecognizable, and yet it would still be a place where matter gathers, burns, and radiates. Stars, it seems, are not a singular idea, but a pattern that can take infinite forms across infinite realities. Some universes could be composed entirely of antimatter. In our universe, matter dominates, with antimatter existing only in rare traces. But in another universe, the balance could be reversed. Imagine galaxies of antimatter stars, shining just as brightly as ours, with antimatter planets circling them. To us, such a universe would be instantly deadly because matter and antimatter annihilate when they meet. But within that universe, it would feel completely normal. Beings made of antimatter might look to their skies and wonder if somewhere, impossibly far away, there are creatures made of opposite matter. The existence of antimatter universes is not just a dream, but a real possibility within physics. It reminds us that even something as basic as what kind of matter exists is not fixed, but one choice among infinite options in the multiverse. Others might be flooded with energy but contain no structure. In our universe, energy and matter form delicate balances that give rise to structure, atoms, molecules, stars, and galaxies. But imagine a cosmos where energy is everywhere, wild and unbound, with no cool regions where matter can settle and condense. Such a universe might glow with endless brilliance, but nothing within it would ever hold together. No stars, no planets, no life, just a sea of untamed energy stretching forever. From our perspective, this would feel chaotic, unbearable in its intensity. Yet to the laws of that universe, it would be perfectly natural. Its existence would remind us that structure itself, the quiet architecture of galaxies and worlds, is not inevitable. It is a fragile condition, and somewhere in the infinite multiverse there may be countless realities where order never once arises. The multiverse may be infinite not just in space, but in time. When we imagine infinity, we often picture endless space, galaxies stretching beyond all horizons. But infinity can also unfold through time. Some theories suggest the multiverse has no beginning and no end, with universes being created endlessly across eternity. If true, then every possibility is not just real, but repeated endlessly, again and again, in ways that defy comprehension. This means there may have been countless versions of our universe before, and countless still to come, each one a slightly altered echo. Our universe feels precious and singular, but in an infinite time, even rarity dissolves into inevitability. Such a vision stretches our imagination to its limits, forcing us to see our own moment in history as one thread woven into a truly endless tapestry. If so, there may be universes older than eternity itself. What does it mean for something to be older than eternity? In ordinary language, it sounds impossible. But if time itself is infinite, then some universes may have existed for so long that their age cannot be measured at all. These realities might feel ancient in ways beyond our comprehension, not billions or trillions of years, but uncountable eons, stretching back without ever beginning. Such universes could be vast, cooled remnants where stars have long since faded, or endless structures that have endured unchanged forever. The idea challenges our minds, because we are used to beginnings and endings. Yet in an infinite multiverse, some universes might simply always have been, their existence eternal. For us, born into a cosmos that began with a big bang, this possibility feels almost impossible to grasp, and yet, it may be real. Some universes could contain physical laws that evolve over time. In our world, the laws of physics feel unchanging. Gravity, electromagnetism, the speed of light, they are constants we assume eternal. But imagine a universe where these rules shift over time, slowly transforming as the cosmos ages. Stars might burn differently from one era to the next, galaxies might form under laws that subtly change, and life, if it arose, would find itself in a universe that never stops rewriting its own script. Civilizations might live under one set of rules, only for their descendants to wake to a cosmos governed by different laws entirely. The very ground of reality would never be stable, always evolving. To us, this seems disorienting. But it may be that constancy is an illusion, and that somewhere in the multiverse, universes are alive in the deepest sense, their very laws changing like the seasons. Others might be frozen, unchanging, and static. The opposite possibility is equally striking: a universe that never changes. No expansion, no decay, no flow of time as we understand it. Such a cosmos would be like a photograph, complete, eternal, and utterly still. From within, it might not even feel like anything at all, since awareness itself depends on change. To us, the idea of a frozen universe feels alien, even disturbing. We are creatures of motion, of cycles and transformation. But in the vast landscape of the multiverse, static realities might exist alongside dynamic ones. They might not contain life or movement, but they would still be universes, complete in their own strange stillness. Such a possibility humbles us, reminding us that even change, something we take for granted, may not be universal across all existence. Some universes may expand into nothingness and then vanish. In our cosmos, expansion is ongoing. Galaxies drift farther apart, and the universe grows larger every moment. But some universes might expand too quickly, racing outward until all matter and energy spread so thin that nothing remains. Such a universe would become a silent void, its fabric stretched until it simply fades away. To us, this sounds like an ending beyond tragedy, a reality vanishing into emptiness. Yet, in the multiverse, even such fleeting existences may be common. These universes would be like sparks, brief flashes of being that burn, expand, and then dissolve into nothing. Their existence would remind us how fragile the balance of forces is, and how easily reality itself can slip away, leaving only silence behind. Others might collapse into singularities and be reborn again. The opposite fate is a universe that does not fade, but instead folds back upon itself. Expansion may slow, gravity may win, and the cosmos may collapse into a singularity, a point of unimaginable density and heat. From this collapse, the new Big Bang could emerge, birthing a new cycle of stars, galaxies, and perhaps life. Such a universe would not be linear but cyclical, endlessly dying and being reborn. Some ancient philosophies imagined this, long before modern physics, a cosmos that breathes, expands, and contracts forever. If true, then somewhere in the multiverse, countless universes are pulsing in eternal rhythms, each Big Bang simply one heartbeat in an infinite cosmic cycle. Ours may even be one of them. Somewhere, galaxies might form from glowing clouds of dark matter. In our universe, dark matter is invisible. It shapes galaxies, but we cannot see it directly. It passes through our instruments like a ghost. But in another cosmos, dark matter might not be hidden. Imagine galaxies forming not from stars we can see, but from vast clouds of radiant, glowing dark matter, shining in colors beyond our imagination. Entire cosmic structures could be luminous, yet built from matter that is invisible to us. Civilizations there might look into their skies and see not starlight but dark matter light, never knowing that elsewhere such beauty lies hidden. This possibility reminds us how narrow our perspective is. We think the universe looks one way, but in truth, the multiverse may contain skies painted in unimaginable ways. Other universes may never form galaxies at all. For galaxies to form, matter must clump together under gravity, cooling and condensing until stars ignite. But in some universes, the conditions for this might never align. Matter might spread too evenly, or expansion might be too rapid, preventing structures from ever taking shape. Such universes would be bleak expanses, with no stars, no planets, and no light. To us, they seem empty and barren, but they would still be universes, governed by their own rules. They serve as a reminder that galaxies, and all that follows, from stars to life, are not guaranteed. They are the outcome of a delicate balance that might be absent elsewhere. And yet, even these empty realities would still exist, silent and complete in their own way. A universe could exist with multiple time dimensions. We know one dimension of time, forward, flowing from past to future. But some theories allow for universes with more than one time dimension. In such a cosmos, events could unfold in ways utterly alien to us. A being might move sideways in time, exploring histories and futures as easily as we move through space. Entire civilizations could develop the ability to navigate timelines like roads, making choices not permanent, but flexible. The very concept of causality, cause and effect, would be different, perhaps unrecognizable. To us, the idea of multiple times feels impossible, but mathematically, it is not forbidden. Somewhere in the multiverse, there may be universes where time is not a single arrow but a vast field, with countless directions to travel, or one where space itself has more than 3 directions. We are used to space as having 3 dimensions: length, width, and height. Everything we know, from stars to atoms, is built within this framework. But what if space itself had more directions, 4, 5, or even more? In such a universe, geometry would be utterly different. Shapes impossible here could exist naturally, and beings there might perceive movement in ways we cannot even imagine. To them, our world of 3 dimensions would seem strangely flat, like a shadow. Physics would change as well. Orbits, gravity, and even the structure of matter might be rewritten by higher dimensions. Though we cannot picture it clearly, mathematicians can describe such spaces, proving they are logically consistent. Somewhere in the multiverse, space may unfold with more axes than we can comprehend. Realities vast and intricate beyond our 3-dimensional imagination. Some universes might contain stars larger than entire galaxies. In our cosmos, stars are giants compared to planets, yet tiny compared to galaxies. But in another universe, the balance might tilt differently. Imagine a single star so immense that it dwarfs entire galaxies, its fusion fires blazing across light years. Around such a star, no familiar systems could exist, no stable planets, no habitable zones, only raw energy flooding outward. Its death would be even more spectacular, collapsing into a singularity or scattering matter across vast distances. A universe dominated by such megastars would feel alien to us. Not a cosmos of many suns, but one where a few titans burn like gods, each shaping reality on their own. Such extremes remind us how finely tuned our own universe is, where stars and galaxies exist in just the right balance to allow for complexity, planets, and perhaps life. Others could shrink reality down to microscopic scales. What if the entire universe was small? Not just its galaxies or planets, but the very fabric of reality existing on microscopic scales. Entire galaxies might be no larger than grains of sand, stars no bigger than dust motes. For the beings who might exist there, such scales would feel perfectly natural, just as ours does to us. From our perspective, though, these universes would look invisible, hidden in the tiniest corners of existence. The fascinating twist is that size is relative. Our own cosmos could, in principle, be microscopic compared to another greater reality beyond. What we think of as vast may be unimaginably tiny when seen from a higher perspective. This possibility challenges the very meaning of large or small, suggesting that in the multiverse, scale itself is an illusion, endlessly relative, endlessly shifting. Somewhere, black holes may act as portals between universes. In our universe, black holes are the ultimate traps, regions where nothing can escape, not even light. But in another cosmos, they might serve a very different purpose. The crushing density at their centers could act as a gateway, linking one universe to another. Falling into such a black hole might not mean destruction, but passage, carrying you into an entirely new reality with its own laws and histories. Some theories even suggest our own universe began this way, as the child of a black hole in the parent universe. If true, then black holes are not just the end of matter, they are also seeds of creation, portals through which the multiverse renews itself. Somewhere out there, beings may even have learned to navigate them, using black holes as cosmic doorways. Some universes could be filled with wormholes like cosmic highways. Wormholes are shortcuts through space and time, theoretical tunnels that connect distant points. In our universe, they are thought to be rare, unstable, and perhaps impossible to travel through. But what if another universe were built from them? Picture a cosmos where wormholes are everywhere, forming a vast web of connections. Travel between stars might be instant, civilizations could span galaxies with ease, and distance itself would lose meaning. Instead of the slow crawl of light across billions of years, movement could happen in the blink of an eye. Such a universe would feel almost dreamlike compared to ours, its structure less like empty space and more like a woven fabric full of passageways. It is a vision of reality where distance is never a barrier and the entire cosmos is interconnected. Others may be sealed off completely. If wormhole universes are networks of connection, others might be the opposite, closed and sealed, utterly isolated. In such realities, there would be no shortcuts, no passages, not even the way to connect with themselves across great distances. The entire universe would be divided into islands of matter that could never touch. Or perhaps more extreme still, each particle might be forever isolated, unable to interact. To us, such universes seem profoundly lonely. Life, if it arose at all, would exist in a cage of absolute separation. And yet, these universes would still exist, each one complete and whole in its own isolation. They remind us how special connection itself is, the fact that light travels, that matter clumps, that we can reach out to one another across distances. Somewhere, universes might bleed into each other, exchanging matter or energy. Most theories imagine universes as separate, sealed realities, like bubbles drifting apart. But what if some universes overlapped, their edges porous, allowing matter and energy to pass between them? Perhaps the strange phenomena we see, unexplained cosmic rays or mysterious fluctuations in space, are whispers of another reality leaking into ours. In such a cosmos, no universe would be entirely self-contained. Instead, each would influence and feed the others, a vast interconnected sea of realities flowing into one another. Civilizations in such universes might even learn to exploit the crossings, drawing energy or matter from neighboring worlds. The idea is astonishing. Not isolation, but exchange. Universes breathing together like organs in one greater body of existence. Other universes may exist forever, never touching ours. Not all realities must overlap. Some may drift eternally apart, sealed within their own fabric of space-time. These universes would exist alongside ours, but remain forever invisible and unreachable. No light, no signal, no crossing. Nothing could pass between them. From our point of view, They might as well not exist at all, and yet, in the multiverse, they could be infinite in number. The thought is haunting. Entire universes, vast and complex, unfolding forever without ever knowing we are here, just as we can never know them. Their existence would mean that isolation is not an exception, but perhaps the rule, with every universe a private story written in cosmic ink, never shared, never read by another. Some universes might allow civilizations billions of years older than ours. In our cosmos, life has had only a few billion years to emerge, and humanity is astonishingly young. But in another universe, conditions might allow civilizations to arise much earlier, perhaps billions or even trillions of years before ours. Such beings would be unimaginably advanced, their knowledge stretching beyond anything we can conceive. To them, the deepest mysteries of reality might be long solved, the multiverse charted like a map. They might even be able to shape universes themselves, crafting realities as we craft stories. The possibility of such ancient civilizations reminds us how small we are, how early in our journey. If the multiverse is real, then somewhere out there are civilizations older than galaxies, holding wisdom as vast as existence itself. Others may end before life ever begins. Of course, not every universe would be so fortunate. Some may be too brief, collapsing or dissipating before life has any chance to spark. Others might lack the delicate balance needed for complexity, remaining sterile forever. These universes would still exist, but they would be silent, lifeless, and unobserved. To us, they might seem tragic, opportunities for life lost before they could begin. But in the multiverse, they are simply part of the endless variety. Some universes blossom with stars and civilizations, others fade quickly, never carrying the spark of consciousness. Together, they remind us that our existence is not inevitable, but rare and astonishing, a fragile moment carved out of infinite possibility. The multiverse could be producing new universes even now. Our own cosmos may feel vast and ancient, but in some theories, it is only one sprout in an endlessly growing field. The process of inflation, a rapid expansion thought to have created our Big Bang, may still be happening elsewhere, bubbling off fresh universes like foam on the surface of a sea. If this is true, then even as we drift through our nights, new realities are being born at the edges of existence. Each one begins with its own Big Bang, its own space, its own time. Some may flourish, forming galaxies and stars. Others may collapse in silence. The idea is humbling. Creation is not a single moment behind us, but an ongoing process, infinite in scope. The multiverse, in this picture, is alive with perpetual birth, forever generating new worlds. Some might be unimaginably strange, with no analogies in our world. When we imagine other universes, we often picture variations of our own, different stars, different laws of physics, perhaps different histories. But some universes could be so alien that we cannot describe them at all. They might lack space, or time, or matter as we know it. They could operate with entirely different forms of logic, unrecognizable to human minds. Even the idea of existence may not apply in the same way. To us, such universes would be as incomprehensible as color is to someone who has only ever known darkness. Their very fabric might not allow for the structures we rely on, atoms, forces, causality. And yet, they would still be real. These possibilities stretch imagination itself, showing us how limited our perspective is and how vast and strange reality might truly be. Others might look almost exactly like ours, with only tiny changes. Among the wild extremes, there may also be universes nearly identical to our own. The constants of physics might be the same, galaxies might form the same patterns, And even Earth might exist, with people, histories, and stories nearly identical to ours. The only difference could be something small, almost trivial. A leaf falling a moment later, a word spoken differently, a life lived with one detail changed. These near-twin universes would mirror our own so closely that they blur the line between what is real and what is possible. Somewhere there may be a universe where you are reading these words, but in a different chair, or on a different night. The thought is dizzying. Our reality is not unique, but one of many overlapping threads in a tapestry woven with infinite variations. Somewhere there may be a universe where Earth has two suns. Imagine standing under two suns, one golden, the other red, their lights mixing across a world with twin shadows. In our universe, binary star systems exist, but Earth does not orbit one. In another universe, though, our planet might have formed around a pair of stars. Days would be brighter, nights shorter, and seasons utterly different. Life under such skies might evolve in strange ways, adapting to constant shifts in light and heat. Perhaps civilizations there would tell stories not of one sun rising and setting, but of two, locked in eternal dance. To us, it sounds like science fiction, but in the multiverse, it could be someone's ordinary sky. The possibility reminds us how contingent our world is, how even the smallest differences in cosmic history could have painted a very different Earth. In another, the moon might never have formed. Our moon is more than a glowing companion in the night sky. It stabilizes Earth's tilt, moderates our climate, and creates the tides that nurtured life in the shallows. Without it, our planet would be very different. Seasons might shift chaotically, climates could swing wildly, and life's path might never have reached complexity. In another universe, Earth could exist just as it does, but without its moon. Such a world might be unstable, buffeted by changes that make long-term survival difficult. Or perhaps it would evolve differently, with life adapting to constant unpredictability. Either way, it would be a profoundly alien Earth, missing the silent partner that has guided us since the beginning. The absence of the moon shows how fragile our balance is, how much of life depends on cosmic accidents. Some universes may allow stars to live trillions of years. In our cosmos, stars burn for millions or billions of years before exhausting their fuel. But what if the laws of physics allowed them to burn far more slowly? In such universes, stars could last for trillions, even quadrillions of years, their light steady and patient. Planets around them would have vast spans of time to evolve life and civilizations. Entire epochs could pass without fear of darkness, with stability unimaginable to us. Life there might feel almost eternal, with stars that never seem to change. The contrast with our universe is striking. Here, stars live long enough for us to exist, but not forever. Elsewhere, time itself may stretch so far that civilizations grow older than galaxies, nurtured under suns that never fade. Others might see stars burn out in mere millions. On the other extreme, some universes might allow stars to blaze through their fuel with terrifying speed. Instead of billions of years, their lifespans might be measured in millions, or even less. Such universes would be restless, full of fireworks, but short-lived light. Planets, if they formed at all, might never have time to develop life before their suns died. Civilizations could barely begin before the sky went dark. To us, it would feel tragic. Entire universes filled with brilliant but fleeting sparks, unable to sustain complexity. Yet even there, beauty would exist. Skies alive with constant supernova, space glowing with the embers of endless stellar deaths. These universes remind us how lucky we are to live in one where stars burn steadily, giving time for life to find its place. Somewhere, planets may form entirely from diamond. Carbon is one of the building blocks of life, and in certain cosmic conditions, it can crystallize into diamond. In another universe, those conditions might dominate, leading to entire planets made of glittering diamond stretching thousands of miles across. These worlds would sparkle under alien suns, their landscapes harder than steel, their mountains and plains shimmering with crystalline brilliance. Life as we know it might not survive there, but such planets would still be breathtaking wonders. Civilizations elsewhere might dream of mining them, traveling across realities to harvest their treasures. To us, the very idea is dazzling, not just diamonds as jewels, but as continents, as entire worlds. Somewhere in the multiverse, such shimmering planets could orbit patiently, waiting for eyes to see them. In another, no planets form at all. Of course, not every universe is hospitable. In some, the conditions for planets might never arise. Stars may blaze alone in empty skies, or matter may remain too diffuse to clump together. Without planets, there are no homes, no surfaces, no worlds for life to walk upon. Such universes would be barren, vast theaters with no stage for stories. To us, they seem bleak, but they too are part of the multiverse's variety. The existence of our own planet-rich universe is not guaranteed but rare, a cosmic gift. Thinking of universes without planets reminds us how fragile our home is, and how extraordinary it is that we live on a world of oceans and mountains, orbiting a sun that has lasted long enough for us to be here. Some universes may allow life to thrive in interstellar space. In our universe, life clings to planets, nourished by sunlight, water, and atmosphere. But elsewhere, conditions may permit life to exist freely in space itself. Vast clouds of gas might harbor organisms that drift like living nebulae, feeding on starlight and cosmic radiation. Instead of roots in soil or oceans, life could spread across the void, floating endlessly between stars. Such beings might grow to colossal scales, booming like glowing flowers of plasma, or they might be microscopic, forming invisible ecosystems in the vacuum. To us, the cold emptiness of space feels hostile, but in other universes it could be fertile ground, rich with possibilities. The thought expands what life can mean, reminding us that our definition is small, shaped by one world, while the multiverse might host life in forms too wondrous to imagine. In others, life could only exist in fleeting sparks. Some universes might never nurture long-lasting stability. Stars may flare and collapse too quickly, or matter may never settle into enduring forms. In such places, life could still arise, but only briefly. Perhaps it would flicker into existence in the turbulence of a collapsing star, or bloom for moments in strange bursts of energy. Civilizations might never form, and awareness might last only as a glimmer before fading. These universes would be filled with beginnings that never endure, a cosmos of unfinished stories. To us, it seems heartbreaking, but it also shows how precious our own long-lived world is. Life here is not just a spark, but a fire that has burned for billions of years. Elsewhere, the multiverse may be filled with countless sparks, never lasting long enough to become flame. Some universes may exist only as quantum probabilities. Our universe feels solid and concrete. But in quantum mechanics, particles can exist in uncertain states, smeared across possibilities until observed. Some physicists wonder whether entire universes might exist this way, as pure probability, never collapsing into a definite form. They would be both real and unreal, hovering on the edge of existence. To us, they might appear as dreams, half-shaped and fluid. If consciousness itself plays a role in observation, then perhaps such universes exist only as potential, waiting for awareness to touch them. The idea suggests a multiverse filled with ghostly realities, shimmering in quantum uncertainty, forever possible but never fully actualized. Others may be as concrete as ours. Of course, not all hypothetical universes are ghostly. Many may be as tangible as the one we live in, with stars, galaxies, matter, and laws as firm and steady as our own. To beings within them, there would be no question of solidity. They would look to their skies, touch their landscapes, and live their lives with the same certainty we feel. The multiverse, then, may span from the dreamlike to the utterly real. Some worlds remain shimmering maybes, while others unfold with as much weight and permanence as ours. The contrast shows how broad possibility truly is. Reality is not one thing, but a spectrum, stretching from probability to permanence. Somewhere, every story imaginable may truly play out. If the multiverse is infinite, then every possible story must exist somewhere. Every tale told, every dream dreamed, every vision imagined, all of them are played out in reality across countless worlds. A universe where heroes triumph, another where they fail. A cosmos where love lasts forever, and another where it is never found. Somewhere, Shakespeare's plays might be history instead of theatre. Somewhere, myths might be real. To us, these are fictions, but in an infinite multiverse, they may all exist as facts. It means that imagination itself is not just a mirror of possibility, but a map of realities, every story unfolding, somewhere, in endless variations. Others may remain forever empty and silent. Not every universe would be full of wonder. Some may stretch vast and hollow, devoid of stars, planets, or even light. Silent expanses, unchanging and barren, eternal deserts of space. They would be universes where nothing ever begins, where no structures form, where no life stirs. To us, they would seem pointless, infinite silence with no voice to hear it. And yet, their existence adds to the richness of the multiverse. Not every possibility is lively or full of beauty. Some are solemn, quiet, and empty. They remind us that our own universe, buzzing with galaxies and life, is not guaranteed, but rare and extraordinary. The multiverse might mean that nothing is unique, not even you. In an infinite expanse, repetition becomes inevitable. If there are infinite universes, then somewhere there are others exactly like this one. Other Earths, other histories, other yous, living the same lives or nearly so. It suggests that nothing is truly unique, that every moment happens again and again, scattered across reality. To some, this feels unsettling. Individuality dissolved into infinity. But it can also be comforting. If nothing is unique, then nothing is ever truly lost. Every version of you, every story, every love, continues elsewhere, forever mirrored in the great expanse of existence. Or it may mean every universe is singular, precious, and alone. Of course, infinity may not require repetition. It may be that each universe is utterly distinct, singular in its laws, its stories, and its beings. In that case, our cosmos is not one of many copies, but a unique jewel, precious because it exists only once. The same would be true of every universe, each a treasure, unrepeatable and irreplaceable. This view gives the multiverse a sense of wonder, not in repetition, but in diversity, every cosmos unlike any other. To us, that means our universe is not diluted by infinity, but made sacred by its singularity. Some physicists believe the multiverse is unavoidable. For some theories of physics, the multiverse is not speculation, but necessity. Inflationary cosmology, string theory, and quantum mechanics all suggest in different ways that multiple universes may naturally emerge from the mathematics. To many scientists, this makes the multiverse almost unavoidable, the logical extension of what we already know. They see it as the next step in cosmology, just as galaxies were once unimaginable until evidence revealed them. To believe in the multiverse, then, is not fantasy but consistency, following where the equations lead. Whether or not we ever prove it, the idea stands as one of the most profound implications of modern science. Others believe it is beyond the reach of science. Yet, not all agree. Many physicists argue that the multiverse, if it exists, lies forever beyond our ability to test. We cannot travel between universes, cannot observe them directly, and may never detect their influence. If so, the multiverse may remain in the realm of philosophy and imagination, not science. This view does not diminish its wonder, it only acknowledges our limits. Some mysteries may be forever beyond us, truths too vast for human reach. Whether the multiverse is real or not, the very fact that we can conceive of it shows how far our minds can wander, even if our instruments cannot follow. And so, our wandering through the multiverse drifts to a close. We have traveled together through strange ideas, from universes made of diamond to worlds with two suns, from endless probabilities to quiet eternities. Each possibility has been like a dream whispered from the cosmos, reminding us that reality may be far wider than we can ever truly grasp. If your mind feels full of galaxies and shimmering paths of possibility, let it soften now. The images don't need to stay sharp. They can dissolve, like stars fading into dawn, leaving only a quiet glow inside. Breathe deeply, and let the thought settle that our universe, this one right here, is already extraordinary. You don't need an infinite cosmos to know wonder. Every heartbeat, every night sky, every small moment of stillness is a universe in itself. If you've found comfort in tonight's journey, you can help guide others here too. A like, a subscription, or even a few words in the comments can be like leaving a lantern for another sleepy traveler to follow. It helps this little space of calm reach new hearts. But for now, there's nothing left you need to do. The multiverse can wait, and tomorrow will come in its own time. For now, you can let yourself drift. The bed beneath you holds you, the night surrounds you, and your breath carries you gently, moment by moment, into the deeper quiet. Rest well, dream softly, and let the cosmos cradle you. Somewhere out there, 1,000 universes are blooming. But here, in this one, you are safe, you are enough, and it is time to sleep. Good night.